A very warm welcome to one and all gathered here. I'm Rohith and I'm here to present my thesis about Sign Language Moderator using Flask and Deep Learning. So let's see what is the need for the Sign Language Moderator, which is SL moderator. It is to provide an effective communication between the individuals who are deaf or hard of hearing. So there is a barrier between the non-signers and the signers, and not everyone can able to understand what the signers are saying, or we can't able to translate. Only few of them can able to do, those who are master in sign languages. Others like us can't able to understand what they are saying. It may cause a barrier to understand even in certain critical situations. So when we try to understand them, it is not much difficult, but some signs are difficult to understand and difficult to translate these signs to an human speaking language form. To avoid this, we and my team has come up with developing a web application. This web application is named as SL moderator. As moderator, we know which is a conversion of a medium to converting a signer's sign language to a non-signer's understandable and readable format of text and speech output. So here we have taken an basic step of an alphanumeric signs, and from this we are able to get those signs and translate into the text or speech format. So here we have planned on this. So first of all, what we are going to do is data collection, which is we have taken an individual input of our data sets. We are collecting those data sets by processing an individual video processing using media pipe and OpenCV, and using the key points we extract the key points and collect those key points, and we set an individual data collection. We will see that in detail, and we have collected the data and we go into the Keras and we get as a Keras model, and using the Keras model we deploy the model into a web application which is runs with the help of Flask, which is a Python framework for developing and web applications. So let's see that in detail. So first we have come up with data collection and extraction of points. So you can see here, using a code of data collection, we are specified the key points from the right and left using the media pipe to identify the key points, and with the help of the key points in that particular position we use this code called the data collection py. So here we have an OpenCV and CV zone 2, which is an anthropical module from the media pipe. From this we are capturing the image, and we set the size of the image into 3000, and each of the data set we are collecting individually. So we are put in a folder called data set, and what type of data set we have specified as a folder. So here the condition what we are given is we have fixed a box around our hands like this. We have created a box from this code, and then we have placed an white image on background for getting a better precision about the data. As you can see here, like this white image we are getting. After that, there might be changes in the height and width ratio in aspect. So we have given like this. So there, you can see if there is a width is more, then the training of the dataset might be loss of accuracy. So to avoid that, we have put in background of the same width as 300 and 300 pixels. So we fit those models inside that. So when we give this to the Keras, it will be able to easily understand and train those models, which may give more accuracy. So this is given for the height aspect, and this is called given for the width aspect. And after each, we are getting this output like this. Each one we have been storing in a folder, which is like this. So I have collected a dataset from 0 to 9 and 8 to Z. So this is an alphanumeric. So we can see randomly pick any. Let's see, I select A. You can see I've collected 30 or more images of a dataset A. Similarly, for each alphabet, for each numeric value, we collect each values as a dataset. So this is the part of data collection, which is like this. Then we get on to the Keras model training. So here you can see this is the Keras model training. So from the dataset, we have specified the number of classes, which as we have 38 classes, including 8 to Z and 0 to 9. From this, we have training path into train and test. We're splitting the data into training and test data, and we will building an CNN model. We are to include in the CNN and LSTM model by convolution network and maxing of ruling, and we have flattened and we have increased and dense. Everything is done here. Then using the Adam property, we compile those models to give a better accuracy. Here we can see we have trained the model from the X and Y and given an approaches of 28 approaches and with a batch size of 32. So here validation speed we have given as 0.2. After the training of the model is complete, we have evaluated the test frequency accuracy. From that we have got an 92% of accuracy from this Keras model.h file, and will also generate labels of text like this. So this is a custom trained Keras model which generates those two things. Then next is we need to get this Keras model and we need to deploy it as a web application. So what we can do is by creating a Flask framework from the Python. Using the Flask, we have specified those video capture and the image offsets we can see here, and each frames what we have to do, and this all you are going to see as an output in few hours, few minutes. So this app route is going to redirect from page to page. So when we run it, it will be deployed in this local host, that is 127.0.0.1:5000. This is a development server. So from this we can able to access this web application. Let's see the other HTML formats. Like this is an home page where we have a navbar and something else, and we have a footer and home page. We have an going to specify this video input here, and this is an about page, and this is the main one where which we are going to perform those sign language conversion to text and speech output. So you can see here this code here we created a video container. This will be going to display a video on the left side, and there is an container which is going to show the text as well as an audio output. You can see here. So I've given specified that, and we have given a script, JavaScript function about on translating those things. Okay, I think let's run this one and see what the output we can get. So basically we have trained a basic model of getting those alphabets and recognizing them, and after they identify, it will be translated into text form and will be displayed on that SLM translate HTML page, which is going to be seen now. From that, it will convert the text into an audio file. Yeah, now the deployment server has started running. Now let's go on to the server. And this is a thesis paper which we are going to publish. So you can see now that get and set as started. So I can see the logo is loaded and icon also gets loaded. So you can see this is our web page, having 3 navigation bars of home, translate and about. And here we are going to deploy that our YouTube video here in the future. And this is the translate page you can see here. So here the translate page, there might be a rendering. Okay, so as you can see, this box has a video image of myself, that is a user, which from we can able to communicate the sign language from here. This will be recorded and convert those signs to a text, and the text will be seen in this black box. So let's see. The first one is
hello. I'm R O H I T H.
so
T.
as you can see, this
Hello.
one is converting each signs one by one as a performing, and you can see it will show the output as well as an audio. I think you can able to hear this.
O
See,
I
I know there is
T.
some background here, so let me shift
I.
this. Okay, let's try it one more again.
Hi. Hello.
Yeah, like this. This one is
Hello.
translating this signs.
Oh,
See, you can
hello.
now it's predicted.
Hi.
Then it will be given that. So without any background
Oh,
things,
hi.
you can able to get this more precisely. So this is our project of sign language moderator, this SLM moderator, and thank you for watching. Bye bye.